Today, we will learn how to convert from any number system to the decimal number system. The method will be take the base of the given number system and multiply each digit of the given number with a power of the base. Take, for example, binary to decimal. The base in the binary number system is 2. So we know the given base. So for example, we will convert 11011 base 2 into decimal. Let's start. First, we take the first digit, the least significant digit or the least significant bit. In this example, it is 1. So we take this bit or digit and we multiply it with a power of 2. So the power of 2 will start with 0. So 2 to the power 0. Next, we take the second digit from the right, the second least significant bit. In this example, it is 1. So we will multiply this with a power of 2, which is 1. So the power will be increasing. The rightmost bit or the least significant bit will be multiplied starting from 2 to the power 0. And the next bit will be multiplied with 2 to the power 1 and so on. And after we multiply, it should be added to the product of the previous digit. Okay, let's get the next bit, the third least significant bit. In this example, it is 0. So this digit 0 will be multiplied with 2 to the power 2. Then we take the next bit, the fourth least significant bit. In this example, it is 1. So we take this digit and we multiply it with 2 to the power 3. And finally, we are at the most significant bit. In this example, it is 1. So this digit will be multiplied with 2 to the power 4. Okay. Next step, since we have this equation already, so next we will calculate. So let's start first by getting the value of 2 raised to its power. So the first one will be 2 to the power 0. The result is 1. 2 to the power 1 is 2. 2 squared is 4. 2 cubed is 8. 2 to the fourth is 16. Okay, we'll continue. We'll get the product of each term. So 1 times 1 is 1. 1 times 2 is 2. 0 times 4 is 0. 1 times 8 is 8. 1 times 16 is 16. We then calculate for the sum of these values. 1 plus 2 plus 0 plus 8 plus 16. We will get 27. This is now in base 10, or this is now our decimal number value. So we can write it without also the subscript. So it is understood that it is a decimal number. What if the given number system is decimal and we will convert it to any number system? So the method will be the same, only the base will change, the target base. Okay, so the method will be to divide the given decimal number with the target base. So repeatedly, the quotient that will be generated will be again divided by the target base until we get the quotient 0. So this is repeated division. Let's take, for example, decimal to hexadecimal number system. We know that the hexadecimal number system has a base 16. The base is 16. So example, the given value in decimal is 567. How do we convert it to hexadecimal? So we start from the given number, 567, and if you remember, the method will be to divide it with a target base. Our target base is 16. So 567, we divide it by 16. So when we divide, recalling short division in mathematics, we will get the quotient 35 and remainder 7. Next is we start with a quotient 35. So we will repeat the division process until the quotient generated will be 0. Okay, so 35 divided by 16. We will get the quotient, which is 2, and with the remainder 3. So since the quotient is not yet 0, we keep dividing. So 2 divided by 16, we will have the quotient 0 and remainder 2. Since the quotient is already 0, then we stop dividing. Now let's take a look at the remainder, starting from the recent remainder, starting from the last remainder that's generated. So we have 2, 3, and 7. So we start getting the latest remainder that was generated. Therefore, the value 567 base 10 is equal to 237 base 16. So we just copy the remainder results starting from the last remainder that we get until the first remainder that was generated. In this example, it is 237. So this is now the answer in base 16.